Record. Hi guys, hi everyone. So this is a special class to explain acceleration due to gravity in previous part. Okay, it was part 4, I think, if I'm not wrong, or part 3. We learned how to find acceleration due to gravity by using this particular diagram. I remember this was the one we learned about. Okay, this was the diagram. You have a trap door, you have an electromagnet. Okay, so now we will learn another experiment like this page. This is page number 17 from our notes. Okay, you have this experiment, which is exactly what I explained you just previous part. Okay, just simplified diagram. If possible, learn this diagram. If possible, do learn this diagram. Okay, learn this diagram. Previous one was, so a 3D diagram. This is just in circuit diagram. Okay, if you want, you can learn it. Okay, and this is exactly that same one. Draw an S versus t square graph, which will be straight line from the origin, that one. But now the experiment which we will learn is method 2, where we will use a tube. Okay, a tube and a cylinder to find the acceleration due to gravity. Okay, so now let's start with that. A cylinder is dropped down the plastic tube. So what do I have? I have a cylinder. This is the cylinder which we are talking about. We have a cylinder. You are dropping it down through through a tube which is also cylindrical in shape, and it has a light gate at the end. Can you see these are light sensors? Now, many of you might not know what light gate is. I might be able to explain it to you what light gate is. So I will let you know that. Okay. And this gate or this light sensor is connected to the computer. So what actually happens is when this tube, okay, cuts the light over here, the timing starts. And as long as it is cutting, the timing starts. When it stops cutting, when it falls down, okay, the timing stops. So you know exactly how much time it took for this cylinder to pass through this light sensor. Okay, so now let's keep it here as it is. So a cylinder is dropped down the plastic tube so that it cuts through the light beam. The length of the cylinder, L, and the height of the top of the tube, H, above the light gate are measured. So you are measuring the length of the cylinder. What is the length of the cylinder? And what is the height of this drop? At what height are you dropping this cylinder from? Okay, fine. Now, what are we doing after that? What they say? Okay, the time T for the cylinder to cut the beam is recorded. Very important. So what are the measurements we have? We have length of the cylinder, we have height of the tube from where you're dropping it, and how long did the cylinder cut the light beam. Okay, now the experiment is repeated several times and an average value of at the T is obtained. Okay, the velocity V of the, you see, remember, you're going to repeat the experiment and you will measure the value of T, average value of T. The velocity V of the cylinder passing through the gate is calculated. So at what speed is this cylinder passing over here? Okay, what is it? Velocity is equal to distance divided by time taken. See, here we are making one assumption. We are assuming that at this point it is traveling at constant velocity. It is not accelerating, though this is actually accelerating, by the way. But we are assuming that when it is cutting the light sensors, it is not traveling, it is not accelerating, it is traveling at constant velocity. Now, the experiment is repeated and the range of values of height and the graph v square against h is plotted. Now, this is something that I have to explain you guys. So what are we doing? We are measuring, okay, different velocity, okay, how much different velocity at different height, okay, but your height is constant, by the way. Okay, yeah, different height, your height, sorry, different height, different velocity and different height. So if you, let's say, sometime we use a tube, okay, we are dropping it from this height, okay, from this height, then we will use the same tube, maybe it's a longer tube, na? Then maybe here we are going to drop it. So we will measure this h1, we will measure this h2, Okay, and we will measure at this tube what is the velocity at this point when there is a light sensor is there. Here also, what is the velocity? Measure that. Then maybe we will use a longer height as well. You can use a longer height. This is H3. Understood? So we will use different height. From there, we will get different amount of velocity, value of velocity, which we will square. We will square the velocity. That's what they wrote over here. What did they write? The experiment is repeated for a range of values of height. How are you measuring the velocity? Velocity is the length of the cylinder divide the time it takes for the cylinder to cut through the light sensors. Okay. And what are we plotting? We are plotting V square against H. Okay. For different values of height, we are measuring different values of velocity. And what kind of graph we will sketch? V square H graph, which will be straight line from the origin. Okay, just like the previous one. In previous, what did we learn? S versus T square, which was straight line from the origin. Okay, now, but why this? Why V square H? Okay, for that, you have to know the equation. What is the equation? You know this equation. Now, V square is equal to U square plus 2AS. Instead of S, we will give H. So can we, what is your initial velocity when you're dropping the cylinder? 0. So V square is equal to 0 plus 2AH. Understood? So can you see this looks like this now? What is this A? A is acceleration due to gravity. And what is the value of A? G. What is the value of A? G. Okay, now look. V square versus H. V is Y. H is what? X. Can you see that? V square is Y. V square is Y. H is X. What is the gradient here? You can say gradient here equals to 2G. So that means your value of G, which is acceleration due to gravity G, is equal to gradient divided by 2. Understood? Online people, everyone. Understood? I will pause the recording.
Yes.
I'm asking you, all of you. Resume. Okay, so some things that I would like to repeat again is that the value is 0 here because you're dropping the cylinder at rest. When you drop the cylinder, remember, we are not throwing the cylinder, we are dropping it. So your initial velocity is what? 0. So this is your C, na? This is your C, right? Y-intercept. That is the reason my graph is starting from 0. You can also write your velocity square is directly proportional to the height which you are dropping it from, because it's a straight line from the origin. Anything that is straight line from the origin is directly proportional. You guys know that. Okay. Then from the equation, you know that since my whatever is in front of the x is always the gradient. So what is in front of the x? What is x? H, na? What is in front of the gradient? 2g. That means gradient is equal to 2g. But my job is to find the value of g, acceleration due to gravity. What is the value of g? Means acceleration due to gravity. Bring the 2 division. Nilu, understood? Gradient divided by 2. Cross multiplication. You know that, na? Or you can also do another way, which other teachers do. Divide both the side by 2. Okay, this 2 and this 2 gets cancelled. This is gradient divided by 2. That also you can do. Understood? I don't know how your teacher taught you, but I usually do cross multiplications and all. If you want, you can do divide both the side by key 2, and 2 and 2 gets key cancelled. Understood, Nilu? Why g is equal to gradient divided by 2?
Yes, now I understood.
You understood. Okay. Now let's talk about this. So here also I wrote it down. Same thing. You see u square is equal to 0 meter per second. So therefore v square is equal to 2gh. Okay. I wrote everything down over here as well. Okay. So this situation is clear. But remember to repeat the readings over here. You have to repeat the readings. Okay. And you should know what is happening in light sensors and everything. You should know that the value of h needs to be changed so that you get different values of velocity. Now, what if I modify this formula? What if they in the examination they try to trick you and modify this formula for you? What will you do then? Let me show it to you. Bhaiya, how will they modify this? Okay, can they make this formula look like V is equal to root of 2gh? Can you make it look like this? Yes. So can I also write it in the form of V is equal to root of 2g into root of h? Can we do that? Why are you sleeping? And it's getting recorded. Listen. So what is my y-axis here? What is the y-axis here? V. So instead of writing V square, can we write V? Yes. And what is my x-axis over here? What is it? Root of h. So can I write root of h as well? So we can draw V square versus h graph. We can also draw V versus root of h graph as well, which will also be straight line from the, wait, I'll pause the recording. It will be straight line from the origin again. But what will be the gradient in this situation? Right. Gradient equals to root of 2g. Understood? Okay. If this root goes on the other side, because see, what is the gradient? Root of 2g only, na? If this root goes on the other side, what does it become? Gradient square, which will be equal to what? 2g. Bring the 2 over here. Gradient square divided by 2 is equal to. So you see two different situations and two different, but in all of them you will get the same answer, almost 9.81, because that is the acceleration due to gravity of our Earth. Okay. So now everybody understood these two different situations. Ashfaq and everyone, do you understand this two? How one
Yes.
equation can be modified to look in two different manner, but the rule is same. You have to sketch a graph and you have to write this. And you know where you're going to face these issues? Unit 3. In Unit 3 of physics, they will ask you this question. They might also ask you this in Unit 1 as well. So you have to learn very, very deeply. So I'll pause the recording. This is the end of this lesson. Okay. How to find acceleration due to gravity by using cylinder and tube. This is method 2. And this is method 1, which I already did in previous video. Stop the recording.